So good morning all. Today we are going to see how to do a 3D assembly of the protected type flange coupling. So here in this coupling we have got the item list or the bill of materials here. We have got shaft end in two numbers, and we have got a flange mail. So the part number 3 is the flange mail. Here you can see the projection here. So this makes it the mail part of this coupling. That is a flange mail, and we have got the shaft associated with flange mail here. So for the time being, I'm going to call this as the mail shaft. And then we have got a key, which is a long key, which is being used to assemble or make a interference bit with the or between the flange male part and the shaft male part. Now next we have the flange female part here. Here you have got a hole here, and this makes this the flange female part. And we have got the shaft here, which is called the which I'll for the time being call the shaft female, and this is being fixed using a key shot, and the dimensions, all the dimensions are given here. And then we need four nuts and bolts. So we have got M10 by 52 bolt, and in order to complete it we have got M10 nuts, and four we need this pair in four numbers in order to give the connection between the flange male and the flange female through this holes being provided here. So in order to do the assembly drawing, first I need to create the parts. So this is my CATIA interface, and now the tree is in product. So this is the product, or this is the assembly module here. I'm going to close this, and I need to go for CATIA part design. So first I need to create the shaft. So I'm going to call this shaft male, and I'm going shaft male. Okay, and next I need to create this shaft. So I'll select this plane here and give sketch, and I need to create a shaft of diameter 40, and since the length it's being as a cut section, the length is not specified, and since the key is of 68 length, I'll assume that this slot is almost having a length of around 90 and 80 to 90 millimeter. So I'll give a shaft length of uh, 100. So in order to do that, first using a center point circle with origin as the center, I'm creating a shaft or circle of diameter 40 millimeter, and I'm going to pad it over a length of 100 millimeter. So here we have got this, and now I need to create this keyhole. Either we can create a plane parallel to this one along the circumference in order to create the keyhole, or we can select this space and make the hole. So I'm going to select this space, and I'm going to create a rectangle. Here I'll use a center point rectangle so that I get the rectangle symmetric with respect to the vertical axis. And to dimension this, what I'm going to do is I'm going to dimension this give this hole the dimension same dimension as that of the key. So the dimensions come like this. It is 12 by 8. So the width is this width is 12 millimeter, and this height is 8 millimeter, and the center is at a distance of or at the circumference of the circle. So I need it to be, since this is 40, the radius is 20. So from here to the circumference, the dimension will be 20. So I'm giving this 20. And since I need to insert this key here, I need a hole which is larger, or the length of the hole should be larger than the length of the key. So this is 68. So for the time being, I'm going to pocket it for a dimension of say 75. or we can give 80 also, since the dimension is not specified, it's up to us. So this is being done, and now I need to do an edge filleting in order to complete this. So 5 or 6 millimeter will do. Or we'll select this plane to do the cut that particular angle. So I'm going to draw a circle of diameter 12 millimeter. The center is exactly here, and this distance I'm going to give it as the length, that is 75 millimeter, and I'm going to pocket it upwards to get that. So this, we have got the shaft mail here. So I'm going to save this as save as, going to create a, in volume G, I'm going to create a new folder, naming flanged coupling protected, and I'm saving this shaft mail here. Again, the female also, we have got the same things here. The dimensions and all is same, except for the keyhole. The keyhole is a little bit shorter here, but that doesn't matter. We can use the same shaft as um, the female, on the female side also. So I'm going to save it as shaft female. So now I've got two parts here, shaft male and shaft female. Now the third one, I need to create a this flange male. So in order to create this flange male, I'll start again a part drawing, flange male. Now I need to create, either I can, in order to create, I can draw the cross section and do it, or I can draw it using circles. So I'm going to select this sketch here, and the outer diameter of the circle is 160, and I've got this 160 circle going from here to here. So what I'm going to do is that first I'm going to draw this 20 with a diameter of 160. So here we have got the circle, and I'm calling the, and I'm specifying the diameter as 160, and I'm going to pad it for a distance of 20 millimeter. Now I'm going to select this face for sketching. And so here I'm drawing two concentric circles. The first one being the outer diameter, that is 160, and the second one is this small circle. The thickness is 4, so this should be 160 minus 4 minus 4, that is 152. And I'm exiting the workbench, and when I'm padding this, I'll get this particular shroud here. The shroud I'm getting, I need to pad it for a length of 12 millimeter. So the dimension is 12. So I've got this shroud also. Now I need to create this shaft here, or the 80 diameter um, part, which is projecting over a distance of 60 millimeter. I need to create that. So I'm selecting this plane here, and I'm drawing a circle with diameter 80, and this should come out over a distance of, since I'm sketching it here in this face, from here to here it's 60, so from here to here this will be 40, so I need to pad it over a distance of 40 millimeter. And I've got a projection on the reverse side also. The projection, this diameter of this projection is 60 millimeter. So I'm going to select the opposite side for sketching, and I'll draw a circle of 60 millimeter, which should be projected for a dimension of 4 millimeters. So the extension is 4 millimeter here, so that 4 is being given. Now I need to create the hole, so I can select this plane, or what I'll do is I'll select here this face and give sketch. Now I need to create the hole here. So this hole, the hole which goes entirely backward, this hole is diameter is 40 millimeter. So that 40 millimeter hole I can give, and the same I can do with, or using the same plane I can create these 4 holes also. So that is also that also I'm going to create right now. So the diameter is given as, since this is M10, the diameter should be 10, and it is positioned at a distance of 60 millimeter, specified by the circle here with diameter 120. And I need to create another circle, again the same dimensions. Dimension diameter is 10, and the length is 60, and I can mirror this circle with respect to horizontal to get this one, and I can mirror this circle with respect to the vertical to get this one. Now keep in mind that we have used this sketch for or this surface for sketching, so I need to pocket it. When pocketing, I will give mirrored extend, and I'll give up to last. So I'll give mirrored extend, sorry, up to last. I'll give dimension and give mirrored extend, and give a dimension which is very higher than the entire dimension. So the 60 is here. So here we have got our flange mail, and the things that we need to add now is this keyhole as well as this filleting. So first I'll select this space to create a keyhole. So again, the same thing or the same method we used for defining the key in the shaft, we are be doing here also. That is, the height will be 8, and the width will be 12, and this point should be at a distance of 20 millimeter to make it the circumference of the circle, exiting the workbench, and I can pocket it up to last. So now I've got my flange mail here, and again filleting needs to be done here. So I'll be selecting this edge here and give a fillet. A radius of 5 or 6 mm will do. So here we have got the flange mail part here. So I'm going to save as flange mail, and the same thing, the dimensions and most of the geometry are same for the flange female also, except for this particular hole here. So I'm going to use this figure and edit it in order to create flange female. So the only difference is that here this protrusion is not here, so this 4 mm projection is not here. Instead, there is a hole of similar dimension to a depth of 6 millimeter from this face. So I'm going to select this sketch here, and I'm going to draw a circle, or I'm going to create that hole. So the dimension of that hole is diameter 60 millimeter, and I'll create a hole of 60 millimeter over a distance of 6 millimeter from this face. So here the sketch I have selected is 4 millimeter away from this face. So a total pocket of 10 millimeter needs to be provided. And here I have got my shaft or flange female. So I'm going to save it. So flange male and female part have been created. The shafts are created, and now need to create the keys. So in order to create the keys, again I'll go for mechanical design, part design, and I'll key long. And since this is a tapered key, um, and usually the taper angle will be taken on the scale of 1 is to 100. But here, in order to get this or make it easy, what I'm going to do is that I'm going to take a scale of 1 is to 68. So every 68 millimeter, 1 millimeter will come down. And for the key, I'm considering that the dimension 12 by 8 is in the middle portion. So here, when we move a distance of 34 millimeter towards the left, uh, and our scale is 1 is to 68, so 34 millimeter means 0.5 change will come. So towards the left, a 0.5 decrease will be there in 8 millimeter, that is this height will be 7.5, and towards the right, when we move 34 millimeter, 0.5 millimeter height will come, so here it will be 8.5. So that is how we are going to create a key. So sketching using the profile tool, I'm going to create the key here. A close profile has been created. So this is 7.5 and this is 8.5 and the length is 68. Now this is my profile here. I'm going to pad it, and I need to pad it over a length of 12 millimeter. Okay. So now we have got the taper side as well as the small side here. In order to easily identify, I'm selecting both these faces, and I'm going to the properties where I'm going to change the color so that it's easy for me to identify which phase is the taper phase and which is the short phase when I go for assembly. So I'm going to save it. So this is key long, and again the same thing, and I can edit to create key short. So I'm going to give the name, change the name to key short here, and I'm going to edit it. So again I'll go back to the same sketch where I've specified the length. Here the length I'm going to give it as 63. So what is the scale that I've considered here? I've considered the scale of 1 is to 63 here. The length is 63. I'm going to change it. So exit workbench. So all the changes are being done here. So key short is also done. So we have got the entire files ready. Now we need to do the assembly. The nuts and the bolts, there is no need for us to create it because it is already there in our catalog browser. So that will call from the catalog browser. So I'll start mechanical design, assembly design. So this is the place where I do the assembly. First I'll call the flange male here. So in order to call it, click this one existing component, and where I would like to call it, I would like to call it on the product. So I click on the product, and now we have got the flange coupling protected. So here we're first going to create flange or call flange male. So I've got the flange male here, and when we call the first part, the first thing we need to do is first we need to fix this part. So I'm going to fix this part here. If you see the constraint, a fix constraint is being defined, and it is being specified by this particular symbol. And now I need to call the second part on again on the product. So I click on the product and I call the shaft male here. So the shaft male is here. I'm going to move it a little bit outside so that I can really give the constraints. So I use the coincident constraint. select this axis, so making it coincident. And in order to, now this can only move along this direction. In order to align the key holes, I need to make this edge as well as this edge coincident or on the same line. So I'm going to give this and this coincident. So that is my second constraint. And the final one is I need to make an offset constraint between this face and this face, and I need an offset of 0 millimeter. So once I update it, I've got my uh, the male shaft and the male flange being assembled here. Now I need to call upon the key. So existing component, again product, and the key long is required here. So the key long is here. I'll just pull it outside for a better view. Okay. So here we have got the tapered face, and here we have got the short face. So the short face should come here. So what I'm going to do is that again I'm going to use the coincident constraint to give coincidence between edges. And a tapered edge with the keyhole edges is not possible. So I'll give a coincident constraint between this edge and this edge, and I'll give the second coincident constraint between this edge and this edge. Again, I can give a surface contact or a contact constraint between this surface and this surface, and an offset constraint between this and this faces, make an offset of 0, which will perfectly fit my key into this. Okay, so that is the male part being assembled here. Now I need to do the assembly of female part. So for the time being, if I'm calling the female part also, it will be overlap, but we'll see how it's can be done. So again, click on the existing component, product. Now flange female. So I am getting a the since the part numbers are same for flange, both the we have changed the file names, but the part number which we specify when we open the part drawing, it's same. We need to rename it, and I'm renaming my new part as flange female. I give OK and OK. So flange female is here, but it is not visible because you can see this is a flange female and flange male, both are on one on top of each other. So what I'm going to do is that whenever I call this key, this shaft and all, since we have used the same file for duplicating it, it will be one on top of the other. So for the time being, what I'm going to do is that I'm going to hide the male parts. Now I got the flange female here. So the female part is here. Now I'm going to call my second part, that is the shaft female. So again, I need to rename it as shaft female here. So shaft female. Um, so I'll just move it outside. Okay. Now similarly, I need to do all the constraints here the way that I've done it in the previous part. So here the inner face should be selected, that needs to be kept in mind. And now I need to call the key. So key short. key short is here. I'm going to move it outside. I need to give the constraints. So between this and this, again between this edge and this edge, and find and a contact constraint between this surface and this surface, and finally an offset constraint here to here with an offset of 0. It's updated. It's a perfect fit. Now I'll just move it, and when I'm moving it I need to just rotate it so that it won't be in line with or on top of our shaft male parts or the male parts when we unhide them. So I'll rotate it and displace it a little bit so that it's easy for us. But if I rotate it or move any manipulation activity on this, the constraints will be gone. So what I'll do is that I'll just check this option with respect to constraint, and then I'll rotate it about Z axis. So I've got this rotated here, and I need to drag it along X axis to move a little bit here. Okay, and that's fine. And I'm going to call my or unhide my other parts which have been hidden. So we have got the parts here, and now I'll do my final assembly where I'm going to make the constraints here between the axis of the shafts. Then the second thing I need to do is that I need to coincide the holes, make the holes aligned. Here if you see, this hole corresponding to this particular key is at an angle of 90° with the hole corresponding to the key here. So the keys are aligned at a 90° offset. So what I'm going to do is that I'm going to give the coincident constraint between this and this hole here. So once I update it, you can see the keys are 90° apart. Now finally I need to give the contact constraint between this face and this face, and here we have got it assembled. Now finally we need to include the nuts and bolts here. So I'll call the nuts and bolts from the catalog browser available here. So catalog browser I'll go to, and I'll select the ISO catalog here. The ISO catalog is there. Then the bolts and hexagon head bolt is here. So I need to select M10 specified here. So as you can see, M10 is here, and we have got M10 by 45. Here the length is M10 by 52. So we'll select 55 from here, 4 numbers. We have got 1, 2, 3, 4. We have got 1, 2, 3, 4, 4 bolts here, but the bolts are not visible right now. So it's somewhere within this. So what I'll do is that I need to again hide all these things. So hide, 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 hide. I have hidden everything. So here I've got the bolts. So I'll do the along scissor axis. I'll just change 1, 2, 3, 4. So I've got it here, all the 4 bolts here. Give OK. And if I want, then it is possible for me to edit length to 52. I'll just show how it is being done. So I'll just check. just check this pad, just double click on it, and I'll try to edit the dimension. Click here, and I can make this 52. I give OK, so that change will be done. Now I'm not going to show this or repeat this everywhere. I just need you to know that this is possible. But what we'll do is that we'll keep on to 55 itself. But this is possible. Okay. So I've got 4 bolts here. Now I'll call the nuts also. So right now we are in the not in the product menu. Here when you see the pad and this option, it's a part menu. So I'll double click on the product. My catalog box is here. So I need to now call upon the uh, nuts. So I need the hexagon nut style 1 here, and that is an M10 that I require. So 1, 2, 3, and 4. So I've got 1, 2, 3, 4, 4 nuts here. Um, can move it along Z axis. Yes. 1, 1, 2, 3, 4. I'll do an X also. 1, 2, 3, 4. Just placing it conveniently. And now I'm going to unhide the parts that was hidden and do my final assembly. Okay, I've got it here. Now I need to do my assembly. So what I'll do is that I'll give the coincident constraint between this and the nut here first. Okay, coincident being given here to here. This one, this one, this one, and this one. The coincident was given, and now I'll coincide it with my 4 holes here. So first here, to here, this to this to this, and this nut to this nut, and just update it. So I've got it almost there as required. Now what I'll do is that I'll take it just outside so that I can give the contact constraint, which is what is required next. So okay, now contact constraint between this phase. I need to select this phase. It's actually not that visible. This phase to this phase, and second one is this phase. Here only the edges are selected. I need to exactly select this phase. That's the issue here. So select the phase is selected. This one, and the third one is this phase. So this one, and okay, sorry. So this phase, this phase and I give update. So all the bolts are conveniently inserted. Now we need to do the same with nuts also. So again, contact between this phase and this phase, contact constraint between this phase and this phase. So contact constraint between this phase, and the final contact constraint between this phase and this phase. So I give update. That is all inserted properly. So here I've got my flange coupling protected type assembly completed. And if we need to create a drawing out of it, you can go for this particular option here. So here all the isometric view is here. There is the front view, side view, and the top view being here. Okay. Flange coupling protected type. I'm going to save this here. So that's all. Thank you.